Good morning. Please start by logging into Clever. All right, so which of these gifts describes your feeling about the snow we have outside? So, welcome to lesson 4. It is week 2, typo there, but we are talking about polarity in further detail and specifically turning our lens towards looking at the water molecule. Some reminders: semester 1 grades were finalized last week, and they are being mailed out to you this week at some point. You should be receiving it here shortly. This is semester 2, so we have a reset of those grades. This is a chance for you to start over if things didn't go the way that you wanted them to last semester. So as you're getting rolling again, please remember to always go in number order with the assignments. Check assignments for comments or questions or resubmissions and those kinds of things. Make sure you watch your ed puzzles all the way to the end, and also check for those comments because I do leave comments to questions there. Make sure that you're trying your best to come to live class and meeting the expectations that we set for you no matter where you are. But the big thing is, let's try to start strong right now. Don't get behind. Don't get yourself into a hole that you can't dig yourself out of. It is way easier to start here and have some tough weeks that maybe drop you down a little bit versus starting down here and having to work your way out the whole time. So I really encourage you guys to start this semester out strong. Thank you guys for being here, for watching this. That's one big piece of the battle. And so I'm proud of you all for doing this for yourself. So this week, we again are talking about the what it means to have a polar molecule. We spent a lot of time distinguishing between ionic polar and nonpolar covalent bonds, but now we need to think about what that means when we look at the whole molecule. We're specifically going to look at the water molecule, which is an exceptional molecule that is vital to life on Earth. And part of the reason that it is so important and so versatile is because of its polarity. So we had 2 assignments that were with the last lesson. There are 2 new assignments with this lesson, including a check for understanding quiz and a lab simulation that, if you have the opportunity to try on your own at home with the materials you have, can get you some bonus points. So let's do a quick review and start with this as our warm-up. So when we take a look at these images here, what do you see and what do you think that they all have in common? So what you should notice is that this ties back to what we talked about in our previous lesson in the notes, is that they have a line of symmetry. Each of these have at least one line of symmetry, and symmetry meaning that if you cut it in half or put a line through it, that it matches on both sides of that line, of those lines. So many of these have, or all of these have at least one line of symmetry. But we need to start to notice that if you put a line through the middle in other directions, that the symmetry is not there, and that's important. Because that's what we're going to have to be looking for different molecules, common molecules. So molecular polarity is, we're not just looking at a bond, we're looking at the whole molecule, because molecules can have more than 2 atoms in them. They can have actually even hundreds of atoms in them. So the easiest way to check if a molecule is polar or not is to look at its symmetry. So thinking of symmetry, this square is a perfectly symmetrical shape because it has multiple lines of symmetry. This shape here is symmetrical up and down, but is not horizontally. This shape here is symmetrical in 2 ways, but not in more than that. And this bottom shape down here is actually not symmetrical, unsymmetrical, not symmetrical at all, because it does not have a single line of symmetry in it. So let's think here. If we draw some lines through this shape, do we think that this is a symmetrical or non-symmetrical molecule? So this NH3 is non-symmetrical because if I cut it this way, the top and the bottom do not look the same. What about this bromine? If I cut it in a couple different directions, is it the same? It is. This is a symmetrical molecule. So when we're looking for the symmetry, then we connect it to if it is polar or nonpolar. So if it is perfectly symmetrical, like this box right here, that means it is a nonpolar molecule. If it is not symmetrical, so if it's missing some lines of symmetry, if it only has maybe one, it doesn't have more than that, that means it is a polar molecule. So based on that understanding, again, this would be our nonpolar molecule. The other 3 would be polar because they are not perfectly symmetrical. They are unsymmetrical. All right. And so looking at some actual molecules, here's a great example. So this fluorine is symmetrical because no matter which way you cut it, whatever's on the other side is going to be the same. So that means it is a nonpolar molecule. This here, if I even just one line of symmetry, I notice that this is not symmetrical. This H and the F on that other side of that line of symmetry, they're not the same. So that means this is not symmetrical and it is polar. Now, let's practice this with several examples. So first identify this as either symmetrical or non-symmetrical, and then identify it with nonpolar or polar, remembering that symmetrical goes with nonpolar, non-symmetrical goes with polar. I know that can be tricky sometimes and can easily get twisted. All right, so what do we think? Okay, so this is a non-symmetrical. It is not symmetrical at all. If I put that line there, they are not the same on both sides. This again also proves it. We're going to be looking for this yellow arrow showing that there's a pull of electrons and there's some non-symmetry there. So that means this is a polar molecule. All right, what about this one? So it is symmetrical. If I cut it this way, or I cut it this way, or I cut it this way, or I cut it this way, no matter what, it is the same, which means that it is non-polar. What about this one? So this is CO2. It is symmetrical. I can cut it this way. I can cut it this way. I can cut it this way, cut it this way. It is the same each time the symmetries are there. So that means this is also a nonpolar molecule. Next, what about NH3? So if I cut it this way, if I cut it this way, oh, now it starts to look a little weird. If I cut it through the middle, if I cut it diagonal, it is not perfectly symmetrical. So if it's not symmetrical, that means it is polar. Again, if we see, when I get to this second slide showing these simulations here of these molecules, if I see that arrow, that signifies that there's a pull of electrons and an imbalance, which should tell us that it is a polar molecule. Okay, what about this one? So BF3 is symmetrical. If I cut it all these different directions, we'll notice that it is the same each way, and that there is no unequal pull anywhere. So it is nonpolar. That symmetrical means nonpolar. All right, what about this one? So you would think that it might be similar to our previous example, but because of that H, that creates this weird imbalance. And so the electrons are not equally pulled. They're going to get pulled away from that hydrogen. It is not symmetrical if you cut it in several directions. So it is polar. All right, and then this is our big example that we're focusing on. This is good old H2O. Do we think it is symmetrical or not? And do we think it's polar or not? So it is not symmetrical. If I notice when I cut it in a couple different directions, it fairly quickly becomes obvious that it is not a symmetrical molecule. It is if you cut it right in the middle, but if I go any other direction, it is not. And again, the simulation shows that there's a huge imbalance with the electrons pulling more in one direction toward that oxygen. So with that idea, where is the partial positive on these molecule or on this molecule? If the electrons are being pulled towards the oxygen and electrons are negative, where is the partial positive going to be found and where is the partial negative going to be found? All right, so if the oxygen is pulling the electrons more towards itself, electrons are negative, that means the oxygen side of a water molecule has a negative charge on it, a partial negative charge. It's not a full negative charge because the electrons are still shared, but there's a slightly more pull of the electrons towards the oxygen, so it has what is called a partial negative. The hydrogens are left then with the partial positive because the electrons are being pulled away from them. Great work, you all. So I hope that that kind of cleared things up and helped with your understanding of what it means for a molecule to be polar. So a couple of things, you have a check for understanding quiz that has been posted. The number 9 H2O Olympics is an online simulation that walks you through a lab. So you need to do the online simulation, watching it all the way through, completing it and answering questions as it goes. At the end, it will give you a PDF certificate to show that you have completed it. You either need to upload that PDF certificate to the assignment or take a screenshot and upload that. So that I can give you credit for completing it. If you turn it in without that screenshot or without that certificate, I'm going to ask you to go back and get that certificate for me, okay? Similarly, if you are going through this and you're like, wait, I have some of these materials, I could do this. Or if you're babysitting your little cousin or sibling and need an activity and you have some of these materials, give this a shot at home and try some of these on your own. I will award bonus points if you take a picture of you trying out portions of this lab and submit that as well when you turn in the assignment. Okay, so those are your two new assignments. The Check for Understanding quiz, this Water Olympics is important because we're going to be talking about what we see going on there next week. So please, please, please try and get to that before we have our next class next week. Also, the polarity practice form, a couple of y'all asked if I could reopen that to retake it. And I thought that was a pretty fair ask. So considering after this lesson, we kind of went through and hopefully cleared some things up and you maybe feel better about how to do that assignment, I have reopened it up. So you should be able to go back and resubmit it or change answers and resubmit it when you're done. Okay. So finish with this as your exit slip. What did you like today? What was easy? What didn't you like? And what was hard? Thank you for your feedback. If you don't have any questions, you can get off here and I will see you in your next lesson. Thanks you all. Bye.